Hello, hello, hello. Hi, my 11th standard nurture series warriors. Welcome, my army. This is your captain, Shreyas, and I'm going live. And this is session number 1 of heat transfer. And today we are going to talk all about conduction. So, welcome, all my lovely warriors. So, time to make ourselves a little bit hot. Welcome, Aishwarya. Hello, Dakshin. Hello, Suchimama. Ara. Welcome, Jafia. Hello, Jones. Hello, Vandakari. Hi, Bhavdeep. Welcome, welcome, welcome. Yes, your Thalaiva, your Capto, your navigator, your master teacher, your teacher is right over here. And it's time to study how does heat exactly flow. If you have been regular on our channel, then you remember that I have already spoken about what is temperature. I have spoken about what is heat. I have also mentioned that heat always flows from high temperature to low temperature. We have also studied the basic properties and the motion and also, the generic properties of gases under kinetic theory of gases. We have also seen how objects absorb, release heat to convert their states of matter. So it's time to study how does heat actually flow from one side to other side. What are the different ways? And that's what we are going to study in this chapter of heat transfer. And in today's class, it's all about conduction. I have divided the class into 2 lectures. First session, one shot marathon for just conduction, modes of heat transfer, conduction in metal, so obviously thermal gradient, the law of thermal conductivity, thermal resistance and the equivalent in electricity, also combination of metallic rods. This is what we are going to study in today's class with me, your captain and your Thalaiva and your navigator. Thank you, Ankit. Was missing your hearts for a long time. Yep. Oh, yes, Ankit, I will definitely check in case if there is some concern out there. Welcome aboard, all my lovely warriors. And I have taken your feedback. I have also seen your comments. And guys, I will change the dark theme probably by next lecture. So for today, we'll just see how the 11th standard students, because yesterday I tried it out with the 12th standard. Today, 11th standard students, I want you to experience the dark mode. Yes, Shreyas sir has shifted to the dark mode so that it is, easy on your eyes, and probably when you are seeing it in the night and all that, these lectures and these slides, it should be convenient for all of you. Also, you're going to get all that I write on this board in the form of annotations in the PPT. I conducted a poll yesterday and thank you for your tremendous response out there. So I hope you have already smashed the like button, and I see so many of my warrior army, already smashing the like button even before the session starts. It just makes my day again. Yes, Anush, I have taken KTG in my last session. Just see my class day before yesterday. You will find it. Okay. Black is super duper, says Jayvant. Vanakkam Tharshan. Hello. Oh, I'll check the answers in the comment. Yes, Ankit. I was super duper busy. That's why I was not able to check it. All right. So thank you for liking. Thank you for hitting the subscribe button. And also remember, if you want to crack JEE Advanced, want to crack JEE Mains, and you have a lot of portions pending, and you want the help of Vedantu, you want to learn online, you don't want to travel, you want assignments, you want tests, you want my guidance, you want the best teachers in the country, we have the JEE crash courses running for 11th as well as 12th, and the 11th standard students will get into the long-term batch of mine. So if you want to check it out, do check it out in the description box. There is a link for joining the 11th standard subscription, and this is as low as 1000 chiller rupees. So you get so many amazing features when you use the discount coupon code, and you get, a lot of crazy offers. So check it out. Let's start today's session with a question. Ventilators, not those ventilators which are there in the hospitals, the ventilators which are provided at the top of big halls. Now, some of you might be like, sir, what the hell is a ventilator? I thought the ventilator is the one which is there in the hospital. They put it on the nose and the mouth so that you can breathe very easily. Is that the ventilator? Okay, well, that's not the one. This is some different ventilator. Those are the openings on the top of a building. Why do you think you have it? Yep. So Yes, Jayant, your eyes are very chill when you see the black screen. I'm planning to change these colors. This color that you see over here, this will be changed because I realize that these texts are not so easily seen. Don't worry, I will come up with a better color scheme. And if you have a better idea in mind for this color, and this color, do let me know in the comment section after the session ends. Okay, some of you are saying A, some of you are saying C. Alright, this is a single choice question, Kalai. Well, Ankit also has a ventilator at his home. The correct answer is C, not A, my warriors. The reason is, see, to bring oxygen, nah, it's not the case. To get the sunlight, no. To provide outlet for carbon dioxide, no. It's actually to maintain the flow of air. What happens when you breathe, when people are inside, you know, the air becomes stagnant. And it might get moist, it might have carbon dioxide, it will also become warm and so many other things. Germs, obviously, yes. So you want the fresh air to come in, the old stale air, which might be moist, which might be humid, which might be warm, all that air should go out. So it maintains the flow. This process of the fluid moving in and out of the container, okay, because of the difference in the states of the gas. The gas inside is having different conditions. The gas outside has different condition. So the gases will diffuse into each other. This process is called as, write it in the chat box. What do you think it is? Yep, what is the process called, my warriors? Is it conduction? No, obviously it's not conduction. It is convection. It is called as convection. And there are three modes of transfer of heat explained beautifully in this simulation out here. Look at this firewood. I'm pretty sure if you have visited Shimla, Ooty, or any such hill station, it may be Mahabaleshwar, Matheran, Darjeeling, no matter where you go, you would definitely have fantasized about sitting near a bonfire in the night. And probably you have the barbecue stick on which you put nice pieces of paneer, or I don't know, some nice pieces of whatever you want to roast on it, and you just make it hot, and you have those garma garam, you have those hot starters out there. So when you do this, the heat which is coming just directly, the rays are hitting you, that is a radiation. Okay, it's wireless transfer, like Wi-Fi, Bluetooth, mobile, it's wireless transfer of energy. So the energy gets transferred because of light, electromagnetic radiation, the radiation, electromagnetic waves. The waves travel from the hot source to the cold source, that is radiation. The second way of the heat flowing is when you're holding that rod. The rod is a physical body. The rod is a physical body. Yep. And a part of the rod becomes hot, the other end, which is in your hand, is relatively colder. And when you have a solid body, then you will see if there is temperature difference, the heat will flow from the hotter side to the colder side. That is conduction. So conduction is the flow of energy via solids. Usually we speak about conduction only in solids, and the energy gets transferred from one point to the other point without the particles themselves traveling from point A to point B. Understand this very carefully. In conduction, particles did not travel, the energy traveled. The energy has traveled. Remember that. Only the energy travels. In convection, it's the particles themselves which go from hotter side to the colder side. So the wind which is blowing, warm air is blowing on your face, cold air is blowing on your face, that is convection. Is that understood, my warriors? Okay. So, okay, that radiation, I don't know what you have learned in chemistry, but here is the thing. Okay, imagine there is a hot side, there is a cold side. There are three ways in which heat can flow. If the energy flows via a material by transfer of energy without the particles moving, only the energy gets transferred from one to other to next. It's like passing the book, standing in a line. You pass the book to the next, that guy passes to the next. That is conduction. Convection is you take that energy, you yourself go and give it to the other point. That's convection. In radiation, there is nobody who transfers the energy. It's wave, electromagnetic wave. What is light? Does light need medium? Come on, my warriors. Does light need medium? No, right? Does mobile waves, satellite waves, microwaves, Bluetooth, anything, do they need medium to travel? No. The rays from the sun enter the earth. There is nothing in between, vacuum. You can communicate with each other. The signals are reaching the satellite. The satellites are outside the Earth's atmosphere. There is no medium out there. I hope this is clear. So when there is no medium, how does the energy flow? The energy will not flow via the particles or the medium. They take the help of waves, and electromagnetic waves do not need medium for their travel, for their propagation. No, light does not need medium. Suchi Mama, many people thought that in 17th and 18th century. Many people thought light needs medium. And then they thought, what is there between sun and earth? How is light traveling between sun and earth? So they thought there must be something. Thousands of people, hundreds of scientists went behind finding that medium, mysterious medium, through which light or electromagnetic waves travel. They all struggled, and after 200, 300 years, people realized that, oh, wait a minute. And that was Maxwell who made them realize, oh, light is an electromagnetic wave. It does not need medium. So that entire work of 200-300 years just went for a toss. So I'll just put some pointers out here. Yep. Yeah, that medium was called as hypothetically ether, but ether was never to be found. Yes, in satellite they need radio waves, and radio waves, they are electromagnetic waves. What is it? Have you not studied the chapter of electromagnetic waves? Just recently I told you. If you are in 12th, then you would have studied it. Okay, my bad. So, electromagnetic waves. Light is a part of electromagnetic wave. Radio waves is a part of electromagnetic waves. Bluetooth is a part of electromagnetic waves. They are not seen, only you see light. So, they are all electromagnetic waves. They have same properties. I hope this is clear. Yep. EM waves, electromagnetic waves, anything, mobile, your Bluetooth, Wi-Fi, all these are electromagnetic waves. Their frequencies are different. That's why you categorize them into different categories. Is that understood, Aryan? Is that okay, my warriors? Please give me a thumbs up in the chat box if you have understood the basic concept of electromagnetic waves. If you thought light was different from Bluetooth, is different from radio waves, is different from microwaves, wrong. Only the frequency or wavelength is different, but otherwise everything is same. They all have electric fields, magnetic fields, they propagate in same wave equation form. You can write all of that. Great, perfect. So for conduction, I'll just put it up over here, all right, so that it is there for all of you. 1 second, let me get that screen and pointer right over here. Yeah, so for conduction, okay, usually we talk about solids. So I will put some pointers over here. No transfer. Okay, no transfer of particles. Okay, no transfer of particles. Only energy is transferred. Okay, only energy is transferred. Medium is necessary. Generally you talk about Generally, you will talk about conduction only for solids, because in gases and liquids, it's the convection which dominates over conduction. So generally, you talk about conduction only for solids. Keep this in mind. Fair enough. Great. Next, convection. Like I said, usually you talk about convection because convection dominates in liquids or gases. So conduction is for solids usually. For convection, you will talk about it only for liquids and gases. And it's the actual flow of particles. The heat is transferred in which the particles themselves will move. Can you see that? The particles will themselves move in that process from hot to cold, from one side to the other side. So you can see this beautifully in this animation, how the particles of the fluid are moving when you heat it. The colder side will, see the liquid particles from hotter side coming over there. You can see the convection currents. Can you see that? Very good. Excellent. Next up, radiation. Like I said, this does not need any medium. So there is no need of any kind of medium. Okay, and these are nothing but electromagnetic waves. And remember one thing, they are very quick, they are very fast, because it travels at the speed of light. Okay, so they travel at the speed of basically light. So these are the things that you need to know about. Now today's lecture is only about conduction. Remember, in day-to-day phenomena or in things around you, all the three things can occur simultaneously. So there could be radiation via these sun. The heat from the sun is coming onto the earth. The earth gets heated up. The heat might travel via the earth's surface from the hotter side to the colder side via conduction. And once the heat flows, it might also create some circulation of wind, which creates convection. So all the processes can occur simultaneously, and you will study this in detail and you will use this very much if you take up fluid mechanics in any way in your engineering. Like if you take naval engineering, or if you take aerospace engineering, or vehicle design, or chemical engineering. So if you take any of these branches, okay, aerospace, aeronautical, naval, automobile, chemical engineering, then you're going to study this in detail, because you need the study of how the heat gets transferred from one side to the other. Very, very important, topic which will be there in these branches. Okay, here is your question next, coming up on your screen. All right. So we are going to go to conduction now. Before going to conduction, here is your question to give you and awaken all the dead neurons or the sleeping neurons. So let's see if you can answer this question. When a Pandu wakes up in the morning and keeps his feet on the floor, he finds the marble floor colder than the wooden floor. Hence, the temperature of whom is more than whom? That's the question. Alright. Lakshmish, you can use MTG, bacha. You can use MTG. Alright. Chalo. Let's see how many of you can do this question. Very interesting question. Figure this out. If you can solve this, it will be amazing. When Pandu wakes up in the morning and keeps his feet on the floor, he finds that the question is blur. Jagdish, probably check your video quality. Just make sure that it is in 720 or 480p. Okay, just think about it. All right. Okay, the name of the lesson, Vaishal, it is heat transfer. Heat transfer. Hello, Molesh. Welcome aboard. Wood and marble. Okay. Now, should I surprise you or not? Do you want to get some surprise? I'll tell you what is the surprising thing. Whose temperature is more than whom? Actually, this statement is itself wrong. In fact, the temperature of marble, okay, the temperature of marble is the same as the temperature of wood. This is very, very interesting. Like, what the hell just happened? Obviously, when I wake up and if I have to walk up on a marble flooring, I will definitely avoid it. I would always prefer wooden flooring, because I don't feel hot in wooden flooring. I don't feel cold in wooden flooring. Then you will be like, then how did Sir write marble and wood have the same temperature? That's why you have to attend my classes. Yep. In space also you will feel the heat of the sun if you stand in front of it via the radiation. Definitely, Kalai. Yes. Hi, good evening, Shiva. Now, the reason is, let's say this is Pandu's foot. Okay, this is Pandu's foot. Okay, this is the foot. All right, beautiful foot. Now, this is the surface. Okay, this is the surface. Okay, this is the surface and this is the foot. Now, understand the surface is cold. Okay, I'll just put it over here. The surface is actually cold. Your body is hot, right? Your body is actually hot. So your body is hot. So what will heat do? Heat will flow. And where will heat flow from? Heat always flows from hot to the cold side. Correct? The heat will always flow. So this is the direction of the heat flow. Now the problem is marble. Marble is a better conductor of heat than that of whom? Wood. So wood is a bad conductor, marble is a good conductor of heat. That means the heat will flow quickly from your body to the marble as compared to, so the heat flow is basically quicker. It's quicker in marble. It's quicker in marble as compared to that of wood. Because of which your body loses heat and you will feel cold. Actually speaking, both of them are at the same temperature. Wood is a bad conductor of heat. That means it will absorb the heat very slowly, aram se. You have to keep the heat for a long time, many minutes. Only then the temperature will reduce. So your body will not feel that. I hope now this is clear. Yep. Is that understood? Many of you did not know this is because of conduction. Many of you thought it is because of something else. Maybe the temperature was less or more. Yep. At winter season, yes, even in winter season, see, the wood, the marble, the stone, the cement, everything is at the same temperature. But you perceive the temperature differently. Because when you touch something, when do you perceive temperature? Okay, think. How will you sense temperature? Only when the heat flows, right? In or out of the body. If the heat doesn't flow very quickly, how will you perceive the temperature then? So that's the reason why when you touch a bad conductor, you hardly feel anything. But when you touch a good conductor like metal, have you touched metal? Okay, think about this. If I ask you in a cold winter morning, sit on a metal chair, will you like it? No, right? Why don't you like sitting on the metallic chair? Because metal is a good conductor of heat. So the moment you sit, tuck se, fat se, it will absorb all your body's heat and you will start feeling cold because it has absorbed the heat. But if you sit on a wooden chair or something else, a bad conductor of heat, then that's it. Your heat is not going away anywhere. I hope that made sense to all of you. Got it? Yeah, so it's not because of anything else, but it is because of conduction. And if you have loved this explanation and loved this question and loved the solution, then go ahead and smash the like button right now. Moving on to the next one. Conduction in metals. Okay. See, if you take a rod, or if you take a long body, or if you take some object, a solid, and on one side you heat it, and one side you cool it, or somehow create a temperature difference, you will see the heat will start flowing from the hot side to the cold side. The heat starts flowing from the hot side to the cold side via the process of conduction. And it is best seen over here. The hot side, the molecules are highly energetic. They are having a lot of energy. They are colliding, they are vibrating, they are having a lot of energy. And the molecules beside, they are very, say, sad. They don't have energy. These molecules are very excited here, which are very hot. They'll be like, hey, come on, wake up, dance, come on, jump. You're like, okay, let's also jump, let's also dance. So they also start dancing, they also start moving around. And then they get very excited because they are getting the energy from here. Then the molecules beside them, which are like, okay, what do we do now? They look at this, okay, we need to dance. So they also start dancing, they also become energetic. And that's how the energy flows from one side to the other side. I hope this is clear. Yes, this is what happens in conduction. So now, if you want to get somebody excited beside you, you need the medium. You can't just dance and be like, hey, come on, dance, hey, come on, dance. But there is nobody over there. So you need medium. You need medium. Without medium, it will not flow. Is that clear? Understood? Oh, I just forgot to turn on my AC, guys. That's why I'm sweating. All right, let me just turn on my AC. I forgot. I think I was suffocating now. All right, where is my remote? Yeah, let me just turn on the AC. I thought I had some post-COVID syndrome or something, why am I not able to breathe? And then I realized, okay, there is no circulation. I need convection in this room. Okay, yes. I'm Lakshmish. I'm from India. Yeah, earlier I was in Africa, and there I used to ride the elephants and even sometimes the giraffes. So yeah, but then I decided to quit my job of riding giraffes and elephants, and then finally I thought maybe I should teach, and yeah, that's when I came to India and then I started teaching. All right, so that's my story. What's yours? All right, so moving ahead. What is temperature gradient? See, we just saw heat flows from hot side to cold side. Excited makes the boring person excited, right? That's what we just saw. Great. Now, this rod will have different temperatures at different point. You will see in conduction. So in conduction, okay, the heat flows. So this is the heat flow, and the heat obviously will flow from the hot side to the cold side, and it creates basically a temperature, okay, temperature gradient. Now, the moment you see the word gradient, you should remember gradient stands for change with respect to distance. So gradient is always change with respect to the distance. Now, temperature gradient is the rate of change of temperature with respect to the distance. That's what it stands for. So, yep. Temperature gradient is nothing but dt by dx. So dt by dx stands for nothing but temperature gradient. This is what it is. If you remember, in viscosity we had velocity gradient, dv by dx. So dv by dx was velocity gradient, dt by dx temperature gradient. Obviously, if you talk about the units, it will be, you know, Kelvin per meter. You can also use degree Celsius per meter. Up to you, whatever you want to use. It's up to you. Okay. So temperature by distance. That's what temperature gradient is. Now, I need this temperature gradient to give you that formula. For heat transfer via conduction. Oh, by the way, many books also use the symbol theta for temperature. Yes, that's okay, perfect. The reason why many books use theta, have you thought about it? Why do books use theta for temperature and not T? The reason is, within some time you're going to see that time is going to come in the equation, and many students and many books, the symbols might look confusing, time and temperature. That's the reason why they use the symbol theta for temperature. Okay, that's the only reason. Otherwise, there is no such reason. It's only because you get confused with the symbol of time. All right. Now, the formula via experiments that you get for the flow of heat via conduction is as follows. You take some body of certain length, certain cross-sectional area. The heat flows from hot side to the cold side. You can see this T2 is more than T1. This is the heat flow. Then the heat current, I'll write it over here. The heat current. Now you'll be like, sir, what the hell is this heat current now? Heat current is nothing but the rate of the flow of the heat. Rate of flow of heat is nothing but heat current. Current is flow of something. So heat current is rate of flow of heat. It is nothing but dq by dt. Units dimensionally, look at it. Q is heat, energy, so that is joules, and time, that's seconds, so joules per second. You can also use calories per second. It's completely up to you. Now this heat current is found out to be proportional. It is found out to be proportional to the area and also the temperature difference, and inversely proportional to the length. This is what it comes out to be. Okay, so because of this proportionality, I need to get rid of that constant. Okay, somehow I need to get rid of this constant. Now what is this delta T? Temperature difference. L, the length. A is the area of cross section. I have marked it all over here. So this constant, when you put it instead of that proportionality, it looks something like this. Heat flow rate is Ka delta T by L. Okay, you can write heat current as Q by T. Heat by time is Ka delta T by L. This is also fine. Is that clear? So this is the formula for conduction. Now you will be worried, sir, what the hell is this What the hell is this K? This is that constant of proportionality. Well, that K is called as the conductivity of that material. It is the conductivity of that material. If K is more, it is a good conductor. If K is more, it is a good conductor. Understand that. So very, very important. More the K, better conductor it is. Less K, bad conductor. As simple as that. Yes, it's very similar to charge flow rate, charge by time. Symbols are also very similar. Q for charge, T for time, charge by time, current. But here, Q stands for heat, heat by time is heat current. Very, very similar out here. By the way, there is a differential way of writing this as well. And the differential way is also something you should know. So basically, if you take a small cross section, if you take a cross section of small thickness, let's say the thickness is dx, the area of cross section is still obviously A only, okay? The area of cross section is still A. Then the differential form will look like this: dq by dt is Ka. The temperature difference between this side and this side, only we are, instead of the big rod, we are taking a small section. This is a small section of that rod. Then it will be Ka dt by dx. This is a differential form. Okay? I hope this is fine, my warriors. Is that clear? So this is the differential form. This is for small sections that I have mentioned right over here. Okay? This is for that. Okay, fair enough. Let's see some questions. Okay, but before that, I have a question for you. dq by dt here. Do you think it will be same, or do you think it will be increasing, or do you think it will be decreasing? Answer in the chat box. Yes, Harshavardhana, this is a part of Nurture series. I will inform the team to change the titles to include the word nurture and also the lecture numbers in case it is not there. All right. Yep, I'll come to that minus sign also. Hold on. I'll come to the minus sign. I'll come to that. Hold on. Yep. Is it same, or is it more, or is it decreasing? Now, a lot of people get this wrong. Please understand, dq by dt here is the same. dq by dt is the same throughout the rod. This is same. This is same throughout. This is same throughout the rod. Now, why is it same? I'll give you a simple example. Just imagine there are 100 people standing in a line. 100 people. The job is to transfer one packet or a box from one person to the other person. You take one, give it to the next. You take one, give it to the next. Understood? You are the molecules of the rod. The packet that you are transferring is the energy. Making it go from the hot side to the cold side. Now imagine the number of boxes you are collecting from here, you will be giving it to the next person. The next person will be taking from here and giving it. Whatever this person takes per second, okay, that's the same amount this person will take per second to the next guy. Agreed? Because if it is not the same, if this first person is taking more boxes per time, and this person over here is taking few boxes per time, that means this person is accumulating those boxes, which is not the case. That means he's storing that energy. Where will he store? Not allowed. I hope this is clear. I agree the temperature is decreasing. That's the reason why the heat is flowing. Imagine if the temperature was same, why would the boxes be transferred? Why would the energy be transferred? That's the whole point. The energy is flowing to heat it up. It's flowing to heat it up. Understand that. I hope this is clear. It was about dq by dt. It was not about dt by dx or anything else. Get it right. So these molecules are taking in and giving in steady state. Okay, very, very important. So all this is happening. This state, when it is same throughout the rod, it is also called as the steady state. Steady state. This is what it is called as, steady state. Keep this in mind. Very, very important things that you are learning in over here is the same. It doesn't matter. Very, very important. Perfecto. Got it? Amazing. Let's see some question based on this. First question itself is very interesting. The rod's cross section is changing. Big to small. Very interesting. Before even starting to solve the question, you need to think whether the heat flow rate across every section, will it be same or will it be different? What is happening? The two ends of the rod of varying cross section are maintained at, this is at 200, this is at 0, 200, 0. In steady state, what do you think is the correct option? Only one option is correct. Temperature difference across AB and CD is same. So if you measure the temperature across AB and CD, it is same. Is it true? Temperature difference across AB is more than CD. Temperature difference across AB is less than that of CD. Temperature difference may be equal or different depending on the thermal conductivity of the rod. It is very interesting. Already Kalai saying A, Ramya saying B. Okay, it's going to be very interesting question to see what is going to happen. Alright, first thing you need to decide. Is heat flow rate same or not? Okay, let me ask you this. Is dq by dt, okay, from A to B, is it different or is it same as compared to CD? Think, is it equal, more than, less than? Only when you get this will you get the next point. Think carefully. Think carefully. It's a uniform rod, but the cross section is different. The rod material, if it's of aluminum, it's aluminum only. Only the cross section is different. Yep. Harshad, this chapter will not end in this session. Conduction will end in this session. Next session, I will cover radiation. Yes, it will be the same. I just mentioned that to you. Heat flow rate is same throughout the rod, irrespective of what the rod is in steady state. It is steady state. The heat which is transferred, whatever it takes from this side, it will give it to the other side. It's the same. Yes, obviously it is the same. Now, what is dq by dt by the formula? It is nothing but K A for that area of cross section AB into delta T for AB divided by length. What is the length of this AB section? It is X. So I'll put X over here. Is equal to K. K is same. Thermal conductivity is the same because it's the same rod material. Area of cross section of CB into delta T of CB upon X itself. Now K goes, X goes. Can you see delta T AB divided by delta T C, sorry, it was CD, not B. It was CD. So CD will be equal to, check this out. Take this CD over here. This AB goes down. Area of AB goes down. Area of CD comes on the top. This was also CD. Okay, this was CD. So what do you think? Area of CD is less, right? Area of AB is more, right? So isn't this ratio less than 1? Isn't this ratio less than 1? If this ratio is less than 1, AB's temperature difference is less, CD's temperature difference is more. So temperature difference of AB is less than that of CD. That means option C is correct. Is that clear? We have completely gone via the formula, nothing else. It's straightforward application, direct application of the formula. So heat flow rate was same. This is the main concept. The heat flow rate is same in steady state. That's what I told you. Then from that, use the formula. Areas are different, temperature difference are different. That's all. As simple as that. I hope this is clear. Very good. Excellent day. Moving on to the next one, coming up on your screen. Now this question is completely upon units. So the units are crazy, let me tell you that. It's not your standard units, so you need to be very, very, very careful. Let's see this. One end of a copper rod of length 1 meter, area 10 to the power minus 3 meter square is immersed in boiling water and the other end is in ice. Coefficient of thermal conductivity is given. Latent heat of ice is given. The amount of ice which will melt in 1 minute is. Let's draw the diagram. Without the diagram, we can't do anything. So this is our rod. Fair enough. Okay, one side you have ice, so this side is basically your ice, and this is at 0 degrees Celsius, and the other side is immersed in boiling water. So this side you have boiling water. So if you have boiling water, that means the temperature is 100 degree centigrade. Obviously heat is going to go from left side to right side, correct? The heat is going to flow this way. Okay, this is how the heat is going to flow, and the length is 1 meter. That's what is given. Now when the heat flows into ice, what will the ice do? It will absorb the heat, and remember latent heat of conversion, it will use the heat to melt the ice. Agreed? The heat which is conducted is used to melt the ice on the other side. Let's find out how much heat is flowing per unit time. So let's just figure out dq by dt, the heat which is flowing because of conduction. Okay, this is all because of conduction. That's it. So because of conduction. So think about it. dq by dt is Ka delta T by L. So let's just write down the formula first. Ka delta T by L. So what is K? Interesting unit, 92 calories. Okay, 92 calories per meter second degree centigrade. This is not millisecond, it is meter second degree centigrade. Very interesting unit. Area is 10 to the power minus 3. 10 to the power minus 3. So 10 to the power minus 3 meter square into temperature difference. 100 minus 0 is 100 degree centigrade. The whole thing divided by length. Length is how much? 1 meter. So 1 meter is over here. Now observe everything carefully. You will start realizing things. This meter and this meter is there together. It will become meter square. Correct? Because it is per meter second degree centigrade. So meter square and meter square cancel. Meter square cancel. Degree centigrade is also below. This degree centigrade is on the top. So degree centigrade also cancel. Only unit left is calorie, and 1 second is there below. So whatever is left is just calories per second. Everybody agrees to this point? Everybody agrees there is no need for conversion as of now. Yes, Ramya, it feels like you need to change it, but you don't have to do anything. Is that clear? Sabrish, if you want to ask any other doubt, please post it up. After the lecture is over, I'll definitely get back to you. Okay? So don't worry about it. Alright. Great. Moving on. Next. 92, 10 to the power minus 3, 10 to the power 2. So this will become 92 into 10 to the power minus 1. Check this out. Is it 92 into 10 to the power minus 1, my warriors? Fair enough. Now this is equal to, this heat is going to melt the what? Ice. This will be the heat absorbed by the ice to melt it per unit time taken to melt it. Now I think heat absorbed to melt it is something which we already know. It is nothing but m into latent heat, and this is nothing but time. Got it? It is nothing but ml by time. Now let's try to rearrange this and try to substitute whatever we know and see what do we get. Remember, LHS has calories per second. I'll try to make sure everything is in calories per second in some way or the other. M, I think amount of ice is asked. M is not known. So M is unknown. Latent heat is 8 into 10 to the power 4 calories per kg. So M will be in kg only. So L is 8 into 10 to the power 4 calories per kg. Do you see this kg and this kg cancels out? Last thing over here, kg cancels, 1 calorie is there, because remember LHS, the yellow part, has calories. RHS should also have calories. That's what is in my mind. Time. Now time should be in seconds. Here it is mentioned 1 minute. 1 minute is how much? It is nothing but 60 seconds. Now do the units match? You don't have to convert, bacha. No need of conversion. Many students do that mistake. Converting calories into joules. Not needed. Everything gets cancelled. LHS has calories. RHS has calories. LHS has per second. This also has per second. Done, done, done. Understood? That's why it is a brilliant question. So what will this end up being? Check it out. This will become 8 into 10 to the power 4. So I can just write it as 4 by 3 because I divided by 2, 8 by 2, 4, 6 by 2, 3. This 0 goes, so into 10 to the power 3 calories per second. Now calories per second, they match. Now I can nicely sit and solve this. So let's see what do I get. I'm just going to sit and solve this and see what do I get. So just put this over here. So 92 into 10 to the power minus 1 is equal to, oh, I forgot that m over here. Just 1 second. This m was also there. So this m is right over here. All right. Moving on. So this will be m into 4 by 3 into 10 to the power 3. So therefore m will be equal to 92 into 3 divided by 4 into 10 to the power minus 4. 92 and 4, this will go 23 times. 23 into 3, that will be 69 into 10 to the power minus 4. 69 into 10 to the power 4 minus 4. So that means it will be 6.9 into 10 to the power minus 3. This is all in kg. Remember, m was in kg. So I think I have got the answer over here. Understood? So beautiful question on how you need to take care of units and also the application of conduction combined with calorimeter. That's why it's very nice. Did you love this question? Was this question interesting? And if you loved it, go smash the like button down there. Yep, it is 6.9 into 10 to the power minus 3 kg. Beautiful question. Very good. Okay. Is this helpful for your upcoming exams? Yes, if you have thermal properties of matter, then watch my previous session. I have also done thermal properties of matter, temperature, heat, calorimeter. It was just done last week and last week and all of that. Just watch that. Okay, perfecto. Kalai, I think I already mentioned and answered your question just some time back. Just rewind it and you will get it. Okay, so the figure shows a system of two spheres, concentric, of radius r and, okay, I think it should be r1 and r2. All right, so let's just assume this is r1 and r2, of course, kept at temperature T1 and T2 respectively. The radial rate of flow of heat in the substance between the two concentric spheres is proportional to. Okay, let's understand what exactly is happening over here. One is hot, other is cold. Do you see the masala? Do you see the material between them? There is some material between them having some thermal conductivity K. So this is basically some masala, some material is added over here. Okay, some material is added over here, and through this material the heat is going to flow. Now what will heat do? Heat will flow from hot side to cold side. Now you have to visualize this. The inner shell is hot, the outer shell is cold, for example. The heat will flow radially. If you draw the radius, it will flow radially outwards. Look at it, that's what the question says. The radial flow of heat. I hope you are able to visualize this. The surface is spherical, perpendicular will be the radius, so the heat will flow radially outwards. So if I have to draw it, all right, I will say that the heat will flow like this. The heat will flow in this fashion. Very interesting thing. This is how the heat will flow. And I'll just call this heat flow rate dq by dt as h. Now, here is my question. If I take shells, let's say for example like this. If I take a shell over here. Okay, if I take a shell over here. This shell, for example, just 1 second. Okay, let me just draw this again, maybe using this highlighter. Or okay, just oops, my bad. All right, let me go back to my pen. All right, so I'll just take a shell right over here. Okay, and this shell, let's say, has some radius r, and this shell, let's say, has a thickness. This shell has a thickness of dr. If I take any shell anywhere from r1 to r2, don't you see heat will be cutting through that shell from inner side to the outer side. No matter which shell you take, the heat will cross that shell's thickness. Now, Tell me one thing. Does it matter how big that shell is for the heat flow rate? Will the heat flow rate be same for all the shells or will it be different? Think carefully and answer this. Think carefully and answer this. Thank you, Bhartam. The heat is flowing from inner shell to outer shells. Will the heat flow rate be different or will it be same? Think carefully. Whatever heat flows from inner shell will flow from the outer shell. Whatever heat flows from the inner shell will have to flow from the outer shell. There is no negotiation in that. That means the heat flow rate should be the same. No, that's where you get wrong. It's same. Think again. There is no difference between this and this rod. The area changes, but the heat which flows is the same for all the cross section. It's the same from small rod to bigger side of the rod. Heat is getting spread out, but the rate at which it gets transferred is different. I'll give you another example. It's just like saying there is one person here who is taking a gift and transferring it to the next person, but on the next side you have two people. They can collect the gift. On the next side you have three people and next you have four. So even if there are two people here, three people there, four people there to collect the gifts, does not mean they will take in more gifts and give it to the other person if they are transferring from one person to the other. It will, at the end of the day, it will get distributed between those people, but the amount of gifts getting transferred from one layer to the other layer will be the same. Understood, my warriors? This is very important concept. So, getting rid of this now that you have understood this, perfecto, heat flow rate is the same. So let me just mention that right over here. Oh, oops. Okay. Let me mention that right over here. Yes, so the heat flow rate is same for all the shells. Very, very important. For all the shells, it is same. Once you understand this, it becomes a little bit easier to write it. dq by dt, which is the heat flow rate, which is Ka dt by dx. In this situation, will turn out to be dq by dt. I just assumed it as h. H is same. K is same. Now, what do you think area will be for that green part? Quickly write it up in the chat box. Yes, integration will be there. Yep, definitely integration will be there. But before that, think what will the area be? How is the heat flowing? Think, it's a curved surface, right? The heat is flowing like this. This is the area. This is the flow. This is the radius. This is the radius. The heat is flowing perpendicular to that area everywhere, radial. This is the radial flow of heat. So that means what should be the area across which the heat is flowing? Think, that green area. What is that green area? It is 4 pi r square. Does that make sense to you? Yep, 4 pi r square. dt is the temperature difference. One side is hot, the lower side is cold, and the temperature difference between them is dt. One side on that layer, one side is hot, one side is cold, so heat is flowing basically. So that difference in the temperature is dt. Okay, fair enough. dx, what is the thickness across which it is flowing? The thickness across which it flows, is nothing but the thickness of that shell, which is nothing but dr. So that's why this will be dr. Is that understood, my warriors? Now, my point is, there are some books which use the minus symbol over here, which is okay to use. It's just like F is equal to minus kx. How often do you use F is minus kx? I don't remember many times. Why don't you use F is minus kx, and why do you just write spring force as kx in most of the problems? Because you already know the direction. So if you know the direction, is there any need for putting the minus sign deliberately? I don't think so. So just like you do it in mechanics, same way over here, I already know heat flows from higher temperature to the lower temperature. So there is no need of putting the minus sign, okay, because as you go front, the temperature decreases. So that minus sign comes because when heat flows from hot to cold, the temperature reduces. So that's why you have the minus sign. So there is no need of that. So many books put that minus sign and you get confused. Should I put minus? The signs are getting crazy. So no need of that. Let's rearrange this and see what happens. Fair enough. So dr by r square is equal to h comes below. So k 4 pi divided by h, k 4 pi divided by h, and I just have dt over here. So I think I need to integrate henceforth. So r raised to minus 2 dr integral is equal to 4 pi k divided by h integral dt limits T1 to T2 from temperature T1 to temperature T2. Here the limits R1 to R2. Okay, I don't need many of these things over here, so I'm just going to get rid of this. All right, let's see what do we get next. Try it out on the piece of paper which you have, rough work. Start doing it and see what are you getting. So when you integrate this, you're going to get x raised to n's integral is x raised to n plus 1 upon n plus 1. So r raised to minus 2 plus 1 upon minus 2 plus 1. So it is r raised to minus 1 divided by minus 1. And here you have r1 and here you have r2. Here you have 4 pi k divided by h. Here you have t2 and then you have t1. Because integral of dt is just t. Integral of dt is just t. Okay, let's try and do this right over here and see what do we get. So first put r2, then put r1. So minus 1 divided by r2, because r raised to minus 1 is 1 by r, minus 1 divided by, put r1 over here. So r1 over here is equal to 4 pi k divided by h, and here you have temperature difference, which is T2 minus T1, delta T. I'll just put it over here. So this will become 1 by R1 minus 1 by R2 is equal to 4 pi k by h delta T. If I take the LCM, it will become R2 minus R1 divided by R1 R2 is equal to 4 pi, correct? 4 pi, look at this, k, h is there as it is below, and into delta T. Now flip it, just flip it, you are going to get R1 R2 divided by R2 minus R1 is equal to h divided by 4 pi k, right? And this delta T will be here. Now don't you see these are constants? Can you see these are constants? H is proportional to this number. The heat flow rate, the radial heat flow rate is proportional to R1 R2 upon R2 minus R1. I have put a modulus there. That's it. I hope this is clear. So I think this should be the answer. Do you see that? H is proportional to, H is basically proportional to, yeah, R1 R2 upon R2 minus R1, whichever is bigger. So that's why I put the modulus sign. That's it. It's one and the same thing. Option A, correcto. Very good. Ankit, please watch my first few lectures of integration of 11th standard, which I conducted it right at the beginning. It's there in the kinematics playlist of Nurture series. Okay. All right. So there you go. Moving on to the next one. Here it is. All right. Looks like some of you got it now. Were you amazed by this question? It doesn't look so difficult, but this was obviously JEE Advanced type of question. Okay, Ankit, but yes, if you want some revision kind of series, maybe we'll do that once the 11th standard portion is over. Guys, I need full support from your side to complete the Nurture series. I want to finish it by Valentine's Day. Okay, I want to be free on Valentine's Day, so that when I go out on Valentine's Day, I don't want in my head, okay, what else is remaining? Oh my god, Nurture series is remaining, Pathfinder series is remaining. I want to be very clear. I want to be very free on Valentine's Day, and I'm pretty sure you too want to be very free on Valentine's Day, right? So let's try to get full support. Let's come in big numbers. Let's finish the series, and let's then go to the revision part. Let's solve some more problems, more sprint sessions, and more PYQ sessions, and all of that. Definitely, we'll do that. All right. So let's get going. Thermal gradient and analogy. What is this? See, it's very simple. Okay. You are going to be surprised because we can make use of whatever we are going to learn in a very interesting way. Observe carefully. See, you have a resistor. You have a resistor. The current flows through it because there is some voltage difference, and by Ohm's law, what do you guys get? The voltage difference is current into resistance. This is what you get. I find some similarities of this in conduction, and here it is on your screen. You have a rod. There is heat current which is flowing. Heat current. So instead of I have dq by dt. So this is basically your heat current. And instead of voltage difference, what I have is temperature difference. I have temperature difference. And maybe I have some kind of resistance. I don't know. Let's find out. I just know one thing. dq by dt is Ka del T by, oops, I need to erase this. Ka del T by the length. Alright. I need to get this in this form so that I can compare it. Voltage difference is same as temperature difference. So I want delta T on one side. So if I want delta T, then everything else on the other side, current is dq by dt. So delta T is here, current is here. So dq by dt is basically your current. Okay, so this is your current. And shift L on the top, and K and A will come below. K and A comes below. Now, I know this is very much similar to Ohm's law. Look at the resemblance. Do you see the resemblance between these two? Do you see the resemblance between these two, my warriors? Very good. Yes, Ramya, I will do it. I'll do it. Don't worry, bacha. I'll do it. If you see the resemblance, what is the equivalent of resistance in temperature, in conduction? It's L by K. So, this number over here, whatever you are seeing, L by Ka, this is then called as thermal resistance. Thermal resistance. Now, why do I need this? So, RTH is L by K. Very, very important formula that you are learning over here. Why is this needed? Because whenever you see heat flowing through rods, multiple rods, connection of rods, you can convert the rod like a resistor and solve it like a current electricity problem. I'll repeat. When you have connection of rods, combination of rods, and you see heat is flowing, something is asked, heat flow rate, temperature difference, etc. Then you can convert the rod into a resistor. What's the value of the resistor? L by K. And then solve the problem. Just solve the problem as if it is a current electricity problem. That's it. Your job is done. That's what it is. I hope this is clear. Very good. Let's move on to the next one. Yep. So I put it up all over here in the form of printed material as well, just in case you want it. All right. So the thermal resistance is L by K. Everything is there. Don't worry, whatever I just told you. Okay. So let's see if we can solve this question which came in one of the previous years. This was asked. So this is a PYQ, and let's see if we can solve this PYQ question. If you want, you can start scribbling and start writing as well and start solving. 3 rods of identical cross-sectional area and area are made of the same metal. That means K is same, area is same. But they form an isosceles triangle right angled at B. Okay, so first thing, let's draw a right angle triangle. Everybody likes to draw a right angle triangle. So let's also draw this beautiful isosceles right angle triangle at B. So this is A and this is C. Fair enough. Next thing, what is given? The point A and B are at temperature T and root T. A is at T, B is at root 2T. A has a temperature of T, B has a temperature of root 2T. Oh, this is hot, this is cold. Got it. Respectively. In steady state, the temperature of point C is how much? So C's temperature is how much? Because TC by T ratio is asked. Interesting question. First, analyze how is the heat going to flow. For that, I'll give you a simple logic. Try to redraw the circuit in its equivalent form. A is at some temperature, B is at some temperature. 1, 2, 3. 3 rods are there. So this B to A. B was at a temperature, A was at a temperature. If you convert it into resistance, the resistors will look something like this. The current is coming in and going out. This current will get distributed between this branch and this branch. It will get distributed. So this distribution will depend on how much resistance is there here, and they may not be actually equal. Do you guys see that? We just assume that the resistance, we just assume that the heat flow rate here, the heat current here and heat current here will be same. But I don't think it will be same. Reason is, whatever you get here and whatever you get here will not be the same. The resistances are different. So think of it this way. When the heat enters in and it gets distributed, it may not be equal. In fact, they might depend completely on the resistance, but one thing is for sure, whatever heat flows here will have to flow through this path. Whatever heat flows here will have to flow through this path. That is the problem. So heat flowing here will be the same amount of heat which is going here because they are connected one after the other. But heat flowing here and heat flowing here, they will not be the same. That is what it is. Everybody understanding it till this point? Now, if that is the case, what I would actually say is that, going back over here, the heat flow rate dq by dt from B to C will be exactly equal to the heat flow rate dq by dt from C to A. Reason is they are one after the other. Basically, they are in series. Do you see that? They are in series, one after the other. Hence, now if I write dq by dt expression, let's see what you get. dq by dt is K into area into temperature difference, which is temperature at B minus temperature at C, which is root 2T minus Tc divided by the length of that rod, which is L, is equal to dq by dt from C to A. That will be K A Tc minus T. So Tc minus T, the whole thing divided by length of the rod Ca, which is nothing but root of 2L. Now K goes, AA goes, LL also goes. Now let's see what do we get. Okay, so I'll get root 2T minus Tc is equal to Tc minus T. This root 2 will just remain. Multiply it over here, you will get 2T minus root 2Tc is equal to Tc minus T. Isn't that what you get? Now let's rearrange this and see what do we get next. Take this T over here. So it will become 2T plus T, which is nothing but 3T. Take this guy over there. So it will become Tc common 1 plus root 2. 1 plus root 2. Now I want Tc by T. So if I want Tc divided by T, I will get this as 3 divided by 1 plus root 2. Yes, this is perfect. This is perfect. I think I have an answer for that. 3 divided by root 2 plus 1. So the concept was that the heat flowing from B to A need not be the same as the heat flowing from BCA because they are getting distributed. But whatever heat flows here will be the same which is flowing here. See if this is correct. Yep, it should be B. Yes, it is B. It is B. Understood? Clear? Moving on to the next question. So, what happens in series combination? In series combination, you will see the heat which flows from one rod and the heat which flows from the next rod is the same because they are one after the other. And because they are in series, the resistances will get added. Remember, resistors in series, resistances get added. So, their thermal resistances will get added. Keep this in mind. The thermal resistance will get added in series. Okay, I'll just go back. Yep. So, in resistors in series, their thermal resistance will get added and the current is basically the same. And remember, R is L by Ka. R is L by K. Because R is L by K, so you need to substitute the values of K in that equation. So instead of R, you will put L by K is equal to, respective L's, respective K's and respective A's. That's how you will get the equivalent K of that combination. Similarly, when they are in parallel, one besides the other, then what happens? The heat will get distributed. Oops, why is it acting like this? Okay, there we go. Yep, please listen to me. Yeah, the heat will get distributed, and because the heat gets distributed, I can say the heat current is distributed. It is distributed. Fair enough. The heat current is distributed. And in this case, again you will see you just have to use the parallel formula. So 1 by R is equal to 1 by R1 plus 1 by R2. The equivalent thermal resistance will be 1 by R1 plus 1 by R2 will give you 1 by R equivalent. Just like resistors in parallel, nothing else. Let's start solving some questions so that you get a hang of it. Yep, this chapter is very similar to electricity. There is a wall. It has two layers, A and B, each made of different material. Both the layers have same thickness, but the conductivity of A is twice that of B. Under equilibrium, the temperature difference across the entire wall is 36. What is the temperature difference across only the first layer? Let's try and do this. First, let's draw the diagram. There are two layers. So let's say we have this layer as A and then this layer as B. The total temperature difference across the wall is 36 degrees centigrade. So the entire temperature difference is 36 degrees centigrade. That's what is given in the question. The thermal conductivity of A is twice that of B. So B has K thermal conductivity, A has it as 2K. Fair enough. What is asked? The temperature difference across layer A. Now if you go and solve it by equations, it will be very lengthy, but if you try to solve it via current electricity method, trust me, this problem will become very easy. Let's try to do it via the current electricity method. Observe this carefully now. Convert the conductivities into thermal resistance. Remember, the thermal resistance is L divided by Ka. L is same for both, area is also same for both. Only K is different as per the question. So if you convert it into resistances, all I will have is two resistors in series, one after the other. Because R is inversely proportional to K, if this is 2K, that is K, that means resistance wise, this will be R and this will be 2R. Does that make sense to you? This is your wall A and this is your wall B, or layer A, layer B. Inversely proportional, you can see that. And as per the question, the entire temperature difference, which means voltage difference, is 36. It is 36. That's how you need to convert it. Think of it like 36 volts. Doesn't matter. Now, the concept that you need to understand is, as simply put, the voltage is across each one of them, or the temperature difference across each one of them. The temperature difference or the voltage difference, whatever you want to call it, this ratio of the temperature difference or voltage difference will be, think about it, the ratio of the resistance. Reason is V is IR. Since V is IR, that means voltage across this upon voltage across this will be resistance across this upon resistance across this, because the current is same. Does this make sense? The current is same. If current is same, temperature difference will be the same as resistance ratio. The ratio of the temperatures will be same as the ratio of the resistances. Ratio of resistance is 1:2. Ratio of resistance is 1:2. Now it's given, like you just found it out, R is to 2R, 1:2. Now think, how do you divide 36 in the ratio of 1:2? Divide 36 in the ratio of 1:2. How are you going to divide it? Obviously 12 and 24. 12 and 24 makes sense. Current is constant. So 12 is across A, 24 is across B. That's it. That's your answer. So the temperature difference across the layer A will be 12 degrees Celsius. Isn't it simple via the current electricity method? Yep. Understood? Unless you want to solve it via those equations K delta T by delta L, you are free to do that, but it will look very complicated. But if you get used to converting it into current electricity method, it becomes very quick and simple. Yes, this is for class 11th. Alrighty, moving on to the next one. Yep, it is 12 degrees Celsius. Perfecto. Let's see the next question. This question also we are going to do by current electricity. Let me warn you in advance. Two identical square rods of metal, okay, and what are they done? They are welded to end like this in the first situation. In the second situation, they are welded besides each other, that means in parallel. In the first case, 20 calories flows in 4 minutes. In the second case, for the same heat, that means for 4 calories, how much time does it take? I'll tell you what to do. Just find the equivalent resistance. That's it. That's all you need to do. Just find the equivalent resistance. Nothing great about it. Let's try to do this. Remember that the thermal resistance is L by K. Correct? L by K. Now both the rods are same. Two identical. It's clearly mentioned. Two identical rods. That means if this rod has a resistance R, thermal resistance, this rod also has thermal resistance R. If this rod has resistance R, this rod also has thermal resistance R. Correct? Now when two resistors are in series, what is their R equivalent? What do you think is the R equivalent in the first case? Think about it. R1 in the first situation will be just R plus R. R plus R, which is nothing but 2R. Very easy. In the second case, they are in parallel. So basically 1 by R2 will be 1 by R plus 1 by R, which is nothing but 2 by R. Take the reciprocal. So R2 will be nothing but R divided by 2. The second case. Very good. Great. Now what to do next? Think. See, voltage difference is the same. Write down your Ohm's law. V is equal to IR. Voltage difference, temperature difference is basically the same. Fair enough. Resistance is different. That means the current will be also different. Got it? dq by dt will be different. Current into R will be, the product of it will be constant. And what is current? Current is nothing but Q divided by T. Q divided, it's not charge by time, that's in current electricity, but in case of heat, it is heat flowing per unit time. And this R, I think I just got it. It is R1 and R2. So I think I know what to do now. The product is constant. The product is same for both. In this case also, in this case also. Let's try to do this. So basically 4 calories divided by the first time in 20 calories, my bad. 20 calories. Okay, let me just write it over here. So 20 calories is flowing in how many minutes? 4 minutes. Into resistance in the first case is 2R is equal to same amount of heat. That means 20 calories will flow in how much time? In the second case. Second case it is R by 2. Now just solve this. Bring T2 over here. 20 goes. 4 goes on the top. Okay, you can just see this. 4 goes on the top. And this 2 and this 2 also gets multiplied as 4. So this will be just becoming 1 minute, which is there as the first option. That's it. As simple as that. It's very easy if you convert it into current electricity. That's it. Done, done. Understood what happened? I'll repeat. Each rod was identical. RR resistance. First time net resistance will be 2R. Next time net resistance will be R by 2. Because temperature difference is same, voltage difference is same. That means current into R will be same. Ohm's law. Now current is heat by time. Resistance is 2R and R by 2. So to keep the product constant, heat by time into resistance, heat by time into resistance. Solve it very simply, you will get the answer. Yep, I hope this is clear. Perfecto, option A is correct. Moving on to the next question, coming up on your screen. 3 rods are made of the same material and are having same cross section. they are joined as shown over here. Each rod has the same length, and to the left and the right you are keeping it at 0 and 90 degrees Celsius. What is the temperature at the junction? Beautiful question on your screen now. Let's try and solve this. This is 0. The right side is kept at 90 degrees centigrade. First thing, in order to find the temperature of this junction, which I do not know, okay, this T itself is a big question mark. How are you going to approach the problem? I feel we should approach it something like current electricity. That will make it very, very easy. I'll tell you how. This is high voltage or high temperature. This is low temperature, that means low voltage. Current, heat flows from high to low. That means the heats are going to flow from here to here. They are going to accumulate. Agree over here? The heats are going to flow like this and come over here. They are going to meet, collect and come like this. So can I say the heat flowing here plus the heat flowing here accumulated will be the net heat flowing in this rod? Agreed? So the heat flow rate dq by dt in rod B plus dq by dt in the rod C, can I say that it is equal to the heat flow rate dq by dt in the rod A, my warriors? Think about it. Perfecto. Now let's start solving this. This is just because they get accumulated. They collect at the junction. That's all I'm going to say. They collect at the junction. That's it. Now let's solve this. Heat flow rate is K A delta T by L, length of the rod. K is the same because it's the same rod, same material. So K is the same, area is the same. Temperature difference for B, 90 minus T, high minus low. 90 is big, T is low. So 90 minus T divided by the length is the same, plus dq by dt for the C rod. So K is the same, area is the same, high minus low. 90 is high, right? Minus lower temperature divided by the length of the rod L is equal to dq by dt for C, for A rod is this one. So K, A, L is same. Temperature difference, this is high, this is low. Big minus small, so T minus is 0. Fair enough? KL goes off. So I just have 90 minus T plus 90 minus T is equal to T minus 0. That's what I get. So I will get this as 180 minus 2T is equal to T. So 180. Take this 2T on that side, it will become 3T. So T will become 60 degrees centigrade, which is option D. Done. So do you see it's very similar to current? Two wires carrying current, when they meet at a point, it forms a junction and the net current outside will be the current which is flowing inside. As simple as that. Okay, so that's all you need to do. Perfecto, Ramya. Yes, it is option B. Yes, there you go. So I have kept some homework questions for you and I'll be putting up the solution as well as the PDF of today's session in our Telegram channel. So this is your first question. Make sure you put it up in the comment section after the lecture ends. This is your second question coming up on your screen. This is your third question. Put up the answer in the comment section, take up a screenshot. All right. And yes, if you want to revise the entire syllabus, you have the JEE crash course which is running for 11th, which will get converted into your long-term batch of 12th standard. And that's what I think most of you are looking for with test series and assignments. And you have 3 packages for 15 days. You get it for 1,350 rupees after using my coupon code SHHPRO. But you additionally get more 15 days. Okay, more 15 days just because of this coupon code. So exactly 1 month. It's very affordable. You can go for the higher packages where you get additional doubt solving on the mobile app in the classic version and the personal mentorship in the plus version. That's what you get. And where do you get all of this? It's all there. If you want to join, it's all there in the description box below. Okay, so if you visit the description box, you will be able to see it. Probably I'm not able to open it now, but yeah, it's there. You can check it out for sure later on maybe. Okay, perfect. All right, so thank you very much for joining in. And I would be definitely waiting to see and hear all your answers in the comment section below as soon as the session ends. Take care, stay safe, And yeah, please study well, work hard. All right, this was your Capto Shreyas, and I was going live. Bye bye, take care, hasta la vista.